quantification. Anything I write, you write, and listen for the extra credit things as we go. So, energy. Energy is the ability to do work. And this is work in the sense of physics. And energy is also the ability to cause change. So cause change in location is going to be the biggest change we're talking about, whether that is the change in location of the actual object, the change in location of an electron, the change in location of an atom. Any change in location, any change is going to be caused by energy. Sorry about my mic here. So basically we can say that energy equals work. And we'll get more to a definition of work is in a minute. We're going to spend most of our time talking about two different types of energy, gravitational potential energy and kinetic energy. Those are the two types that we are going to work on quantifying using the formulas, etc. So gravitational potential energy, gravitational potential energy. Potential energy is not stored energy. Potential energy is energy that could cause change. It could do work. It's not at the moment, but it could. Two different ways to symbolize this. Energy gravitational is one way to do it, and another way to do it is gravitational potential energy. So either way, that's what I mean. So gravitational potential energy depends on three things. The amount of energy depends on gravity's acceleration, which we know is our magic number of 10. Acceleration due to gravity is 10 meters per second squared. It depends on the height at which the object is being held above the Earth. It only has gravitational potential energy if it could fall. Height is h, and the mass of the object measured in kilograms. So those three things determine the amount of potential energy it has because it can fall. Let's put that up here. Because it can fall. So you need to set what your height equals 0 is. What is your baseline? Is that your tabletop? Is that the floor? Whatever. So our formula for all of these, if we increase the gravity, we have a direct relationship with the amount of gravitational potential energy. So this is a direct relationship. We also have a direct relationship between gravitational potential energy and height. So the higher we hold something, the more energy it's going to have, the more work it's going to be able to do when it lands. And we also have a direct relationship between the energy and the mass. The heavier something is, the more massive it is, the more work it's going to be able to do when it lands. So think about something landing on your foot, and the change that's happening is going to be the arrangement of the bones in your foot. So if I went to Jupiter and had a stronger gravitational pull, more change would happen to the bones in my foot. If I held the bowling ball higher, more change would happen to the bones in my foot. And if I had a heavier ball, more change would happen to the bones in my foot. So please write the word ouch on the back of your notes and circle it for extra credit. So based on these three relationships, we can come up with the formula for gravitational potential energy is that it equals the mass of the object times the acceleration caused by gravity times height. So gravitational potential energy equals mass times gravity's acceleration, I'm just going to write gravity, times height. And all three of those variables have an equal importance. So if I double the gravity, I double the energy. If I double the mass, I double the gravity, the energy. If I double the height, etc. Now, based off of this formula, we can come up with the units for energy. You might know that this turns out to be the joules, but my unit is going to equal kilograms for mass times meters per second squared for gravity times meters for height. So what this works out to, I could simplify this by doing kilograms times meters squared divided by seconds squared. But if we remember that a kilogram meter per second squared is actually a Newton, then my unit for energy is a Newton meter. So my energy unit equals 1 Newton meter. Now, we said that energy equals work. Well, work involves moving something, and to move something, you need to apply a force. So work equals force times distance, or work equals F times D. Force is measured in newtons, distance is measured in meters, so energy equals work. They have the same units, they are the same quantity. Energy is the ability to do it, work is what is done. And so we can simplify this even more to the joule. And we do it in capitals because it's some guy's name. And so the unit for joule is the unit for work and for energy. Now the next one we're going to talk about is kinetic energy. Now we're talking here about the kinetic energy of large objects, and we're going to use EK or KE, either one depending on when the worksheet was written, honestly. EK is probably what you're going to see on standardized tests. KE is what I put on my worksheets. But kinetic energy depends on two things. It depends on the velocity of the object. If you get a bowling ball moving faster, it's going to do more damage to your foot. And it depends on mass. If you have a heavier bowling ball, it's going to do more damage to your foot. The relationships, though, while being direct, are not both linear. The velocity relationship is exponential. It is an exponentially direct relationship, which means velocity is extremely important, which is why speed limits are so important to follow. Because if you increase your speed a little bit, you're increasing your kinetic energy a lot, and you're going to increase the amount of change you can do to your car when you crash. Please write the word crash on the back of your paper and circle it, please. Mass, though, goes back to having just a plain old direct relationship. If I increase my mass, I'm going to increase my kinetic energy. And for this, we come up with the relationship of 1/2 mv squared. And this is another formula. I try not to do this very often, but this formula, you're just going to have to take it as word that this is what it is. We're not going to go through any kind of lab that would derive this one. The potential energy one is easier to do. We could derive that one in class. We're not going to. So we're going to use these formulas. The unit, again, is the joule. Any kind of energy is going to be measured out in joules, whether it is nuclear energy or heat energy or chemical potential energy or electrical energy. It's going to be measured out in joules. How many newtons can the object be moved? Or how many newtons of force does it take to move the object? And our last topic here is the law of conservation of energy. Now you guys can all quote it for me, I am sure, but we are going to go to a 9th grade level of understanding and we are going to quantify it. So the law of conservation of energy is energy cannot be created or destroyed. So we have this neat little relationship that, I'll write it out in words and then we'll do it in formula. So work gives an object potential energy if it is lifted up. So if I spend some force lifting an object up a distance, I am giving it gravitational potential energy based from the work that I do. So work equals potential energy. And then that potential energy turns into kinetic energy as it falls. When I drop it, it starts to move. The farther it falls, the more speed it picks up, the more kinetic energy it gets. And then the kinetic energy, when it lands on something, is going to do work on the object it lands on. So if I take a bowling ball and lift it up, my work, my force that I'm applying against gravity to move it up a distance is giving it potential energy. I drop that bowling ball, it picks up speed as it falls, it increases its kinetic energy as it falls. It lands on Play-Doh, changes the location of the Play-Doh particles, does work on them, and the work that I did is equal to the potential energy that the bowling ball got, which is equal to the kinetic energy that the bowling ball accumulates, which again can go back and is the same as the work done. So we can flesh this out. Work equals force times distance equals kinetic or gravitational potential energy, which is equal to mgh, which is equal to the kinetic energy, which is equal to 1/2 mv squared. So this is fun. This means that I can take any two parts of this and pull them out and set them equal to each other. So I can say that work equals mgh. I can say that force times distance equals 1/2 mv squared. I can say that gravitational potential energy is equal to, I don't know, force times distance. This is the law of conservation of energy in formula form. And I can solve for any variable as long as I'm given the rest. So this is a lot of fun right there. Please write done with an exclamation mark on the bottom and circle it for extra credit. Thanks for hanging in there. Bye-bye.